Okay, the next set of problems is 8.5. 8.5 is a crucial section. We need to talk about a bit of fractions, a bit rationalizing, but fractions, some of those you've seen, and I'm sure some of those you haven't seen, but they're going to come up for us. That's why we're covering those. So on page A31, we're going to talk about things that you know a bit, which is simplify. How do you simplify a problem? Well, if it's a fraction, you try to find the factors so that you could reduce. Kind of like saying I have 20 divided by 14. We say, well, the top is 2 times 2 times 5. That would be the factors of 20. The bottom is 2 times 7. And the idea was you could always cancel out a ratio of 1. And you're left with 10 over 7. So that's reduced. We're going to do the same here now that we know how to factor. X minus 3. Nope, x minus 6, x plus 1. And the denominator is x plus 1, x plus 10. And you notice this is a ratio of 1, which means they must be identical. Otherwise, you can't cancel them. So that's one aspect that comes up every now and then. Adding fractions is something else. If you have the same denominator, that's a simple problem. Just be careful with a minus in front of a fraction. That belongs to the entire top. That's negative 2x minus 10. So now if I simplify the top, that's 3x, and that would be it. The 10's cancel out. Okay, straightforward. How about this problem? Well, the denominators don't match. You find the LCD. The LCD for this problem is x minus 3. Your goal is to make both of these fractions over the same denominator. X minus 3, x plus 3, I'm sorry. So the LCD is already there, but this is missing an x minus 3. Whatever you multiply the bottom with, you must multiply the top with. Again, in math, you're allowed to multiply by 1 or add a 0. And that's basically it. So over the LCD, now I'm looking at a 5 plus x multiplied by x minus 3. If the denominator I just dragged with me, at the end, if I could cancel things out, I would, but besides that, that's pretty much it. I'm looking at x squared minus 3x plus 5 divided by x minus 3 into x plus 3, and since the top doesn't factor, we're done. Now, the next set of problems is something new you're not used to. I'm going to try and work those out as simple as possible. So we get, this is a fraction, we get the least common denominator. I notice it's 2 radical x. Well, what is this missing? This is missing the whole 2 radical x. Whatever you multiply the top with, you multiply the bottom with, a ratio of 1. You're allowed to multiply by 1 in math and add a 0. That's it. Now, over that denominator, if I multiply those two, wouldn't that be 4x times x minus 2 plus x minus 2 squared? Now, I know you're not used to this, but do you notice, I know I could FOIL, distribute, and do all of these awesome things, but do you notice that this is the same in both? Can't I factor that out? That's going to save me a lot of time. What's left out of this piece? A 4x? What's left out of this? The plus you copy down. If I take x minus 2 squared divided by x minus 2, isn't that just x minus 2? And you'll notice things worked out nicely without me even working that hard. So I know you're not used to seeing this, but there's always a first time, right? And here it is. So this is something that's going to come up for us, and we need to be able to clean things up that way. Now this next problem, there are 2 ways of doing it. They really want us to factor, and that would be much neater if you could factor. Most students don't see it this way, and since this is not a calculus class, I am going to write it as a fraction. Right? Minus square root of x plus 1 over 1. And here, what we're going to do, we're going to find the LCD. Now, there is a shortcut. If all of those happen to have the same denominator, I'm going to show you a trick. If all of these happen to have the same denominator, you could ignore the denominator, because when you multiply by the reciprocal of this, when you multiply, I'll show you. So, the LCD is square root of x plus 1. This is missing a square root of x plus 1. Again, you could only multiply by 1. And this is missing a square root of x plus 1. You can only multiply by a ratio of 1. Now, you could jump ahead and say that is x minus, if you multiply a square root by itself, wouldn't that undo the radical? Over x squared, the square root of x plus 1. And what happened here, you really took square root of x plus 1 minus x plus 1, and you left that over the square root of x plus 1. In the denominator, you took this, and instead of dividing, you multiplied by the reciprocal. And that turns out to be a shortcut. That happens every time. If I have what's known as a complex fraction, a fractions divided by fractions, if every term in this complex fraction have the same LCD, they undo each other, and you could save yourself a lot of pain that way. And you notice what this is. This is x minus 1 over x squared, square root of x plus 1. Those cancel out, and I'm left with a negative 1 over x squared, square root of x plus 1. Again, not pleasant, I do understand, but something that you must get out of the way. I'm going to move the LCD and put it right there, just to make more room. Here we go. So if I look at this problem, I notice here the LCD is right there, that piece, because this is the cube of that. So the LCD is 2 times 3 plus x squared to the 3 halves. What's this missing? Nothing. And what is this missing to have the whole LCD? It's missing a 2 and a 3 plus x squared. Because if you multiply those, 1 plus 1 half is the 3 halves. There it is. Again, something new. You want to write it as a radical, you can. I don't know if that helps more. I'll show you that. This will be negative x plus 6 plus 2x squared. That would be 2x squared plus x plus 6. 2 into 3 plus x squared to the 3 halves. And that doesn't factor. You're done. If it helps for you to write this as negative x over twice the square root of 3 plus x squared cubed plus 3 over the square root of 3 plus x squared to the 1, you're welcome to do that. And then you see that you have to multiply this by 2 over 2, which is the 1. Alright? And the last aspect of this section, again, these are 2 quick review sessions, but I thought I'll mention them since they appear on and off, and I didn't want to keep on saying, you know what, look, you should know this, look, let's just get them in a section and get this out of the way. Rationalizing the denominator is when you look at the denominator and you say, okay, that's 3 times 7. How does this work? A square root, for anything to clear a square root, it must appear twice. So I'm thinking, if I had 3 times 3 and 7 times 7, that would be 3 times 7, and it's radical free. Perfect. But the only way I can get 2, 3, since I have one of those, the only way I can get 2 of those is if I multiply this by 3 times 7. And what was the deal? I'm allowed to multiply by 1. So how do you make that a 1? If I was to do this, the denominator will be a single radical. 3 times 7 times 3 times 7. It's right there. And that's this. And the top is simply 3 times square root of 21. And wouldn't you say that those cancel out? And you're left with the square root of 21 over 7. rationalizing doesn't come up as much, but we do see it every now and then. And how would you rationalize those two? Well, if you see two terms, you multiply by the conjugate. What's the conjugate? The same exact thing, but with a minus. Why is that? Because you're aiming for this. If I multiply two terms, if this is minus and this is plus, which is known the conjugates, guess what? I'll get the first squared minus the second squared. And since a square cancels a square root, that's the key. So if I was to multiply this by exactly the same things, I'm guaranteed the denominator will have the first squared minus the second squared. And what that guarantees, that's 36. And this 2 cancel that radical, and guess what? The denominator now is radical free. Isn't that nice? Now we come to the problem. You can just multiply this. You're allowed to multiply in math by 1. How do you make that a 1? Whatever you multiply the denominator with, you multiply the top with. I wouldn't distribute if I was you. And what do you notice? 13 divides 26 2 times. This will be 6 minus radical 10 all over 2. If you were going to split that up, you could. You don't have to. This does come up. This is coming up in the next section, 1.5. Something where you have to rationalize. Well, we need to get rid of the radical in the denominator. Since I see two terms, I know the drill now. I'm going to multiply by the conjugate. The same exact thing, except I'm going to switch that sign. Whatever that sign is, I got to make it the opposite. I'm guaranteed the denominator will become the first squared, which is x, minus the second squared, make sure to use parentheses, x plus 5. And if I distribute that n, so the denominator is simply a negative 5. As for the top, well, if I multiply the bottom by this, to make it a ratio of 1, there it is. I wouldn't distribute, that's safe me work on the long one. And wouldn't these two cancel out? And I have to distribute the negative. So change both of these signs. And there it is. And the homework is right there. Again, we're going to tackle those two sections and get them out of the way.